Hello, my name is Khatsko. I will present to you our research about optimizing file routing in EDI systems, and we will use new naming principle to improve EDI system, EDI messaging. Other authors of this research are Olga Yanholenko, Nataliia Khatsko, Andrii Kopp, me, and Yevhenii Shebanov. The aim of this research is to find a way how we can improve EDI messaging. EDI messaging in current form have problems, and sometimes it leads to big business problems, delays, which need to be resolved one way or another. So our aim is to find some solution how it can be updated, improved. So object of our research is process itself. We will try to simulate EDI messaging between two systems, and we will compare some kind of basic implementation with our improvement system. Subject will be study of the method that will prioritize messages compared to other messages. So one of the things that we are doing is reordering messaging that we are sending through EDI. Relevance of this research, as I already told, this is existing problem of the business. Current businesses have problems with EDI system. Sometimes they lead even for SLA violations, which is quite a problem in a business in enterprises. And it still are not solved, neither in technical implementation, neither in any kind of proposed systems for EDI. We will we did work on identify patterns, how is EDI system works, what can be improved in first place. We proposed our solution for reordering messages, and our main part is to encode information into file names of messages itself. We implemented a test solution that we can use to compare with basic solution. We introduce a idea how to reorder messages and therefore improve EDI systems even more. And we trying to eliminate possible negative consequences when EDI messages could not be sent due to one of the nodes of EDI system is blocked and could not get messages from other parties. A little bit about EDI. EDI can use a lot of different files, for example, X12, EDIFACT, ODET, XML, etc. The information that are inside, meta information that present inside of messages could be message type, could be file format, file structure, and size of the message itself. Sometimes you need to read file itself of the message. You need to analyze context body of the message itself to understand what actions need to be done or what kind of sorting, in first place, sorting. Should this message, how important is this message, and when we should send this message, should we skip it for now and pass more important messages? Our first proposal, is how to encode this needed information inside of message itself. How we can put all needed information that needed for sorting, ordering, how we can put all this information inside of file name of the message itself. And on the left, you can see example of XML EDI message where we have order. This is type of message. It could be either invoice or something else. And the most important fields are also sender and recipient. Sender is an physical address inside of a EDI message of the system that will send the message. And recipient, therefore, is the same, is physical address inside of EDI system of recipient EDI system. As you can see on the right, you can see example of a defect message, which is also the same message, but in a defect standard. In businesses, as of right now, usually any kind of names could be used for files itself. So you can see a couple of examples that was used and changed a little bit from the real life businesses. And you can see every business trying to include the information needed only for business, and which is de facto is unneeded, for example, on receiving side. This is example of typical EDI system, which has on the left, we have a big storage for messages of two type, XML and everything else. So XML going to inbox in storage, everything message of every other type going inside of C inbox storage. And usually in real implementations, one system will work with one type of file and everything else system can read, but will de facto transform it, convert into main system, in our case XML. Therefore, our storage needed to, for any random file, to be first converted to the XML file type. And after that, all XML files are in main storage, which will be sent in FIFO order, first in, first out. We use part of the system is a part of systems that will go for operational system, will actually track physical file and file system. We have processing queue, one for actually sending files, one to conversion file. We have two services, one service sending file, one service is converting file, and on the right you can rough representation of partner storage when they get messages in. So the first in messages go to the storage on partner side. As you can see, couple of problems. Problem number one, when you send message on your storage, you actually do not know when this message will be sent, what is already in the box, and if we include conversion service as well, you can see that actual sending queue will become a little bit random. It mixing messages that come from users and come from conversion service. Secondly, we need to, there is, in current implementations of EDI systems, there is nothing to prevent of handling errors on partner side. So if partner side cannot receive message, the whole system on sending queue will be blocked and will not proceed. It de facto, if one partner cannot work at the moment, cannot proceed messages, we are actually blocking all messages to all partners that we need to send as fast as possible in real time. Therefore, it creates real problems and need manual reset. Again, our first proposal is to speed up uh, speed up processing queue and include information, all needed information that will allow us to reorder both queues. Include all this information in file names, therefore we will no need to find files in file system and read it, parse them, etc. So we propose to have one standard template how to name your files inside of one EDI system. It could be in future the standard could be global standard for any kind of business, or it could be some kind of config for current EDI implementation. We chose for our research to experiment with and compare it a next type, where we include message type, underscore, priority symbol, it's high priority or usual priority, underscore, recipient GLN, and sender GLN. And after that, we will use UUID to make sure we don't duplicate message. We will don't have duplication name for different messages, because actually it's real possibility that messages from us to one exact partner with the same type of message and both normal priority would be used. Therefore, we need to add UUID to make sure that we will not duplicate file names for different messages. After that, we'll use format after dot, as usually. On the right bottom corner, you can see example of this messaging. And this is all information needed for our experiment. Later, we'll discuss what could be done in future searches. This is how our architecture is looks like in our implementation. So we still have storage. We still have storage for all types of messages. We still have two queue, one queue for converting file types, files, and one queue for actually process files and send them to the partners. But we have special additional element that can have access to both queues, and this element can, using file name, have all needed information. It can reorder queue. And if you have, for example, simplest example, if you have messages with high priority, it will always move them to the beginning of the queue to make sure it will be sent as fast as possible. If we have information that one message to one partner cannot be received, is we cannot finish sending it, we will downgrade priority for this partner in both process and queue. But mainly, this all needed for system to reshuffle it and make sure that only most needed things are used. Before fully implemented and comparing our options, we did try to compare only one part of the system, is about how fast we can send message, and for that how fast we can retrieve GLN GLN identification. This is a physical address in EDI system. So without it, we cannot send message. Therefore, when we have GLN ID of a partner, we can send it because we have both file and GLN of recipient. So blue is old normal systems that used, it's the factor the same as used in almost every project, in every business. And red is our implementation when instead of parsing the message before send, again, we just extract GLN from file name of the source. And it's several orders magnitude of difference. So we definitely saw promising results. Therefore, we started implementing whole system and comparing results. This will be a little bit later. About condition of the full experiment. We had 6 types of messages. APROC, DES, add, invoice, order recipient, and rect out. You can see we used usually a couple of thousand of messages of different type. We did use 6 types of messages to trying to simulate as much as possible normal flow of messages, but we actually compared only 3 of them. We did use GS1 XML version 3.6 standard, but for APROC, we did use 3.4.1 standard due to our ability to implement them. We did check messages in queue each 100 milliseconds, and on the bottom you can see example of file names that we generated for our experiment. Again, one slide later I will provide your results, but in the future there are a couple of additional things that we can use. For example, dates of that used in the message, date that need to be done for product delivery, or expected payment, etc., etc. So there are a lot of more information that could be encoded in the file name, and it highly depends on exact business and what business needs. By which criteria business decide which messages are more important and which messages are less important. Here, experiment of end-to-end results. So this is the time that message from the stage of being in storage on the sender to the time when message was in storage of recipient, with plus minus 100 milliseconds, because we checking this information each 100 milliseconds. For APROC messages, if we use old standard system, the average processing time was 2 and 2 seconds, and by file name it was 1 and 9 seconds, which is 17% increase. For invoice, the same was 34% increase, and for order it was 22% increase. So we definitely have results. We definitely can compare them and have achievement, can have measurable results. So our idea already working. It's already could be implemented in real solutions and provide real results, but with better fine tuning for exact business, we can even improve these results. In conclusion, during the course of this work, our research, we could identify a problem, real problem of the business. We could propose a solution, even implement the test version of this solution and test it with basic implementation. We definitely have results. Our solution is to encode information inside of file names, which is increase time, increase speed, which messages can be processed, And in short terms, we need to read message only once inside of the system. And after that, we can always know on each stage of life of message, we can know exactly what to do with this message and what we want to do with this message, how we can compare. And important part as well is to ability to change queues, make them dynamic, and make sure they are representing business needs. And in future, we want to implement systems that can react on problems. For example, if one of partners cannot receive messages anymore, and make sure that we continue system as a whole continue to work even if one partner does not, and it does not block sender side of EDI. Thank you for your attention, and that's all.